Thank you very much for coming. I'm going to be talking a little bit about agent-based simulations. And I think this might be a little bit more of a technical talk than some of the talk that we have here. So feel free to, at the end, feel free to ask me any questions regarding anything that I might go through that's a little bit more weird to you. But I think overall it should be fine. Let me just. So my name is Eduardo. I'm the co-founder and CEO at 3Sigma. And 3Sigma is a consulting and engineering firm that we do a series of services. We do from code audits to code development, and we also do a lot of things in the economic side of things. So we do economic audits for DeFi protocols, and we also do agent-based simulations, which is the topic of the talk today. And we also have a strong emphasis on market research, and you've probably seen some of our blog posts on Twitter, like it was mentioned. So yeah, hope you enjoy the talk. So yeah, what are agent-based simulations? And I'm going to start to explain a little bit what's the approach. So agent-based simulations are pretty much computational simulations that aim to understand how a certain environment and a certain set of agents relate with each other. So we have pretty much a set of independent agents that are modeled to act on their own self-interest. And then we have an environment which is pretty much what the agents interact with. And so these agents, inside a certain environment, we might have different type of agents. And then we try to understand how the environment and the agents develop throughout time. That's pretty much the idea. And yeah, it's good to sort of understand what can happen with a set of agents with their own self-interest and what happens to the environment when those agents interact inside that ecosystem per se. We have here a very simple example. So let's say that we have a set of people that are spread around a room, for example, like this one. And let's say that a fire starts inside the room. We might want to see and better understand how quickly can the people leave the room. So this sort of approach would be good to understand how these agents act, because we might have different type of agents, and then the actions of some agents might actually change the way the other agents act. For example, we might have some agents inside the room that start panicking a little bit more and start pushing people over, and obviously that's not great to make sure that everyone lives in a faster way. So it's always important to be aware, and what the simulations allow us to do is to actually become more aware of what are the possibilities and what obviously can be done to sort of mitigate those issues. So to explain a little bit what this looks like in the real world, I'm going to be giving the example of banks. So obviously the example of banks is good because it's a good analogy to crypto, and this approach has been utilized massively by banks more since 2008, obviously, and the European Banking Authority has actually made it mandatory for banks inside the EU, and the EU is just an example. This happens in many jurisdictions around the world, but it has actually made it mandatory for banks to stress test annually their portfolio against a series of market conditions. So, for example, in the case of mass mortgage defaults, we need to model many different things. We need to model, like I've mentioned, the environment and then the agents. In case of the environment, we might be looking at, for example, the GDP of a given country, the unemployment rate. We might be looking at, if we are in a pandemic or not, for example, like COVID, amongst other things. And then in the side of the agents, we might want to model a different distribution of age inside the population, because we have a working class and we have a non-working class. We want to model different wages. We want to model different wealth levels. We want to model many different things. And then when we're running the simulations, what we want to make sure, what we want to see happening is mortgages being written. Then we want to, throughout time, simulate the population paying off those mortgages. And then obviously we need to understand how many defaults are happening inside those mortgages being paid, because in really bad market conditions, we have people getting fired, we have a lot of different things happening inside the environment, and the goal would be to understand if the bank becomes solvent or not, if they can withstand those defaults, how many defaults can they withstand, and what can they do to make sure that less defaults happen, or at least that they have a better response to those defaults. So yeah, what does this look like in crypto? So In crypto, we have seen agent-based simulations being used by many different protocols, namely Compound and Aave, which are on-chain money markets, are very famous for a big emphasis in this sort of economic risk and making sure that the protocol is parameterized in a way that is safe for their users. So they're a great example of this sort of approaches being used. And then obviously we have the case of Terra Luna, which is a great example of what happened could have definitely been simulated and it could have been predicted. Which doesn't necessarily mean that it would have been avoided, but at least it means that people would have been much more aware of the risks that they are incurring. It's a great example because it really comes down to game theory. So we have many different actors interacting with Terra Luna. And what happened in reality was we got to a point where we have USD holders, we have Luna holders, and then we have liquidity providers for both of these assets. And once USD depegged, and let's say that this could be one of the initial state of a simulation, these USD holders are incentivized to redeem their USD for Luna, which was the mechanism that the Terra Luna ecosystem used to make sure that that USD hold this peg. So they're incentivized in actually redeeming their USD for Luna, and subsequently they will want to sell their Luna to make sure that they don't incur any losses. They're not necessarily wanting to be exposed to Luna. So this rational actor, what it does is it redeems USD, it gets Luna, and then it sells Luna off the market. If this happens at scale, Luna holders will not be incentivized to hold Luna. So the second actor would be the Luna holders, which suddenly are also incentivized to actually sell off Luna, which puts further sell pressure in Luna to a point where we might have the liquidity providers suffering impermanent loss, and then suddenly they are also incentivized to actually remove their liquidity from the market and then sell it off, which further worsens the state of the system. And it gets to a point where we have a death spiral, no one is incentivized to do anything but sell, and then we see what happens with this graph. So yeah, this is exactly the sort of things that could be better understood using the agent-based simulations, because we could better understand what are the conditions that then trigger that spiral. That would be the goal in the example of Terra Luna. Yeah, so what do we see as being a consulting firm? We talk a lot of protocols, and there are many different types of projects. This approach is not necessarily the best for every sort of DeFi project. I've selected a few where definitely we've seen a lot of interest, and it's very feasible to get tangible results from using this approach. First of all, we have the collateralized deposition, so money markets. This is interesting because these protocols, these on-chain protocols, they need to remain solvent. They need to make sure that every debt is paid. They don't want to accrue bad debt. And so it's good to see, and these protocols, then they have different types of mechanisms to make sure that they don't reach insolvency. And these sort of simulations are good to better determine how these mechanisms work, what has to happen for these mechanisms to work, and what are the scenarios in which maybe the protocol is at danger. In the case of crypto, a lot of what these protocols can do to sort of mitigate this is actually the risk parameters that they have built into the mechanisms of their own protocol. And these sort of simulations give them a very good aid on what parameters should the protocol have given a certain set of market conditions. Yeah, the second example is obviously the peg resistance of a coin. So here with the USD, I gave the USD example. It's a really good example. We want to make sure that a stable coin remains pegged, and we want to understand what can be done to repeg that coin once it depegs, and we want to make sure that there isn't a global incentive for all the agents that are interacting with the system to actually further the depeg, which is something we want to avoid. So it's good to know before things happen what to do. So yeah, that's pretty much what we're trying to do. Not so much on the security side. We can actually have this approach to test on-chain liquid strategies, which is a little bit of a different approach, but it's also very valuable to understand how to adjust the risk for these different strategies. These can be trading strategies or liquidity provision strategies, whatever it might be. It's always good to know what you're facing, how you should change your strategy throughout time, and having this sort of approach is good because you can only not backtest your protocol against what's happened before, but you can actually also create different scenarios and test it against, imaginary things that haven't happened but might happen in the future. So that's also very interesting. So yeah, changing a little bit the focus here now. I'm going to talk a little bit about what these agent-based simulation frameworks actually encompass. This is a lot. It's very hard to get these simulations actually going, and it's a lot of effort to make sure that you're accurately simulating an environment and that you have agents that are rational and that are doing what they're supposed to do. In the case of the banks, well, these banks, they have their own portfolios and they have their own things, and they can model this in any way that they want. In the case of crypto, we have a little bit of an extra difficulty, which is the fact that we are interacting inside the EVM. The EVM isn't the greatest execution environment for testing and for some other things. As a lot of you might know, there's been a lot of emphasis in creating tooling to actually help the development on top of this execution environment, and creating a simulation framework poses the same kind of problems. There's a lot of issues with deployment of protocols. There's a lot of issue with the setup of the state of these protocols. For example, sometimes you deploy a protocol, but then you actually need to set up, for example, the pools of an AMM. You need to initialize liquidity, and a lot of other things that actually appear when you're trying to do this. And it's actually, these simulations, in reality, they end up being very, very computationally heavy. So it takes a lot of effort to be able to optimize the simulations, because we're wanting to run a lot of independent agents. We're wanting to run big time frames. So maybe we're running a simulation that's 1 year long, and then we want to run many different simulations simultaneously. So this poses a very, very big challenge for people, and especially these independent teams, because we see the teams that have interest in running these simulations are actually small DeFi teams that don't have a lot of resources to actually developing and optimizing these sort of frameworks. So what we see is that this poses a big issue. And it's kind of sad, because this sort of approach would actually save a lot of users' funds and it would make the space much safer in general. But in reality, well, actually teams have been starting to have many more DeFi researchers and quants. We've seen that, like, probably in the last year, because of what's happened in the market, people are starting to be much more careful with these sort of things, making sure that their mechanisms make sense, make sure that the incentives inside the protocol are aligned, and that the actors are all doing actions that actually, further improve the state of the protocol and not the other way around. And this sort of approach is not widely used simply because it's not available. It would be very good to see more teams using this. Unfortunately, right now it's not the case. Although we have seen some teams that maybe simplify the framework and have more of a simplistic approach to the problem, which is already good to see, because there is interest, but it just doesn't produce the same results. It's just not as accurate as we would all like it to be. Another problem with this, so because this is the case and most of the teams are small and don't have resources to do it by themselves, what happens is that most of the teams actually outsource this to consulting firms like ourselves. In general, we see two problems with this. The first one is the availability. So the teams that are actually modeling these agents and running these simulations end up being only this very small amount of consulting firms and not the protocols themselves, because this work is being outsourced. And the second problem we see is actually transparency, because these consulting firms, they run the simulations on their own side, they produce results, and then they might even write a cool report explaining all the different risks and what they've found out from these simulations. And at the end of the day, the teams don't have a way to make sure that the simulations are accurate and to confirm those results, which poses to be a big problem. So yeah, I'm just going to give a couple of examples of what we've seen small teams doing, and some of the problems specifically with backtesting, which will be something that you'll see a lot of teams doing. And the way backtesting is you pick up the transactions that have been submitted on chain, and you actually replay them and you try and understand how your actions play throughout time. The problem with backtesting is that you can't actually persist the state of your actions. So what you actually need to do is, for example, let's say that you're trying to see how a trading strategy would work in the past. You're ignoring the impact that your actions have in the system because you don't have any other way to do so. And this is what we have on top. If you're actually persisting the state of your transactions when you're backtesting a protocol, let's say that, for example, we have an AMM, and we have a whale placing a big order on top of that AMM, what would happen is that all the transactions that come after that are buy orders will revert because the tolerance, the slippage tolerance that they have wasn't calculated at runtime and the state of the system changed, which is not good at all. So we can't really have a dynamic system, which is what we have represented in below, because if you have a dynamic system and these transactions are built in at runtime, then that slippage tolerance would have been adjusted to the changes that the simulation itself did to the state of the system. Yeah, so we also see a lack of modularity in the way that teams are approaching this. What I mean by this is that if you're wanting to test a certain protocol, everything that you build is actually built for that specific use case and for that specific protocol. Let's say that, for example, we have a protocol that uses Uniswap, and we have two different protocols that use Uniswap. If we are modeling for the first one, that first protocol, we're going to model everything for that specific use case. And then the second time, we're trying to model the second protocol that also uses Uniswap. There isn't a lot of things that can be reutilized. The deployment scripts and maybe the setup can be, but a lot of what's behind the agents and stuff will not be. And that actually poses a big problem because it's not a scalable approach. We need something that's a little bit more modular, where we have an independent Uniswap module that works for everything that wants to integrate it. Yeah, so just to finalize, we're actually wanting, and the motivation behind this speech is that we're actually building something like this at 3 Sigma. We're looking to fix all of the issues that I've stated above, namely not only have backtesting available, but to have a dynamic simulation environment, to have something that's modular, and to take away all of the difficulties that is to run an infrastructure like this. So yeah, if you have any questions, please, if you have any questions or you'd like to learn more, please, you can meet me after. I'm very happy to talk with people and get some feedback on what they would like to see on a framework like this. And thank you very much.